Hello everyone. In last lecture, we have discussed about the programmable input-output port IC 8255, and we have discussed what is the need of peripheral devices. After that, we have discussed the pin diagram of 8255. 8255 is a 40-pin IC. It consists of three ports, port A, port B, and port C. These signals are the PA0 to PA7, PB0 to PB7, PC0 to PC7. These are the port A, port B, port C. And every port have 8 lines. You can see pin number 1 to pin number 4 and pin number 37 to pin number 40. All these pins are associated with port A. Here, pin number 10 to pin number 17 is port C. Pin number 18, 19, 20, 21, 20 up to 25. This is port B. After that, pin number 34 to pin number 27 is data pins for the transfer of data. Then there is chip select signal to enable the chip, and then read and write signal for writing and reading data input, then reset and VCC. These are the main pins of 8255. Now next, what is the internal architecture? What are the different blocks, functional block present in the 8255 IC? So basically, this internal architecture is divided into two groups. One is group A and another one is group B. So group A consists of port A and higher order bits of port C. Means this is from PA0 to PA7. Means all 8 lines are present in group A and 4 lines from C4, PC4, PC5, PC6 and PC7. These 4 pins are included in the group A. All total 8 pins of port A and 4 pins of port C. Now in group B, it consists of all input pins of port C, port B and 4 input pins of port C, PC0 to PC3, and all input output port of, this is port B, from PB0 to PB7. This is included in the group B. I will mark this like this with red mark. And now next, group A means port A, port C. These two together controlled by group A control, and these two controlled by group B control. So there is a provision of group A and group B control, and these are connected with internal buses. These are the internal buses, and here we are applying 5-volt power supply, ground connected to the ground pin is connected to the ground. And now next, these internal buses are connected with the data bus buffer. So this data bus buffer is connected with the data lines of 8086. So whenever we are using this peripheral IC, then this D7 to D0 lines will be used for the data transfer from the processor. So these lines from D0 to D7 are used for the data transfer. Now there is a read-write control logic. What is the function of this read-write control logic? This read-write control logic manage all the internal and external transfer of data and control word. This data bus buffer store the data temporarily, but the transfer of data, transfer of control word is done by this read-write control logic. This is the responsible for managing all these functions. And this data bus buffer store data temporary, and this is responsible. This is basically acting as an interface. So this is used to interface internal data bus. This is internal data bus, and this is these lines connected with the process. Now, this is the block diagram of 8255 IC. Here you can see chip select signal. This chip select signal is active low signal, and this is used to select this 8255 chip. This 8255 IC will be enabled when this chip select signal is enabled. How you will enable this chip select signal? By connecting this CS with the 0 input. This is actually active low input. So when you are connecting this with 0, then it will be enabled. So here we are using chip select signal to activate this. So this is all about the architecture of 8255. In next class, we will discuss the control word. How this read-write control logic control the working of this whole circuit. Till then, thank you and have a nice day ahead.